So how can sound escape when even light itself cannot escape? What you're actually listening to is vibrations.
You got to hang on that object to get those data.
Voyager 1 and Voyager 2 are only two examples of how crucial space probes are to our comprehension of the universe. These probes are supplying us with data on the furthest reaches of our solar system in real time, even though we may not have the opportunity to directly investigate them for many years. However, some odd data that the Voyager 1 probe is returning from deep space has NASA engineers stumped. What are the weird messages coming from deep space that Voyager 1 is sending? Is there a reason to be alarmed or not? Join us as we explore how Voyager 1 was touched by an unknown force in deep space. For nearly 45 years, the Voyager missions have played a crucial role in space research, giving some of the very first and most important looks into the real state of our solar system. The Voyager twin spacecraft from NASA have turned into time capsules for their generation. They have an 8-track tape recorder for data storage and about 3 million times less memory than modern cell phones. They also transmit data at a rate that is about 38,000 times slower than a 5G internet connection. The pioneers of space explorer operations are still the Voyagers. Our Sun and its planets sail through the galactic ocean known as interstellar space, which has never been investigated by any other probes. To acquire a fuller picture of our solar system and the interactions between the heliosphere and interstellar space, scientists are fusing data from earlier missions with observations made by the Voyager spacecraft. No other spacecraft has been able to revolutionize our understanding of the Sun and its influence like these have. Every Voyager spacecraft acts as an ambassador for humanity, carrying a golden record with music recordings, greetings in a variety of languages, images of everyday life on Earth, and diagrams of basic scientific principles for anyone who might come into contact with the spacecraft. The record's gold coating serves as a cosmic message in a bottle. At the rate that gold corrodes and decays in space, the data will remain intact for more than 1 billion years. Experts have been astounded by the strength and direction of the interstellar magnetic field, and the new information has even sparked discussion concerning the shape and activity of the heliosphere, the Sun's magnetic domain. The heliosphere, long thought to resemble a comet, may really be more spherical than previously believed. And does it get bigger and smaller as sunspots appear and disappear, or does it stay mostly the same? In this investigation, the spacecraft has offered some tantalizing clues. Astronomers believe the interstellar medium begins when the solar wind, which is the flow of charged particles coming from the Sun, comes to an end. This plasma or ionized gas presses against the cooler, denser interstellar plasma flowing around it, acting like a pebble in a stream. Similar to how the top of the Earth's troposphere is referred to as the tropopause, and the heliosphere and heliopause refers to the hollow cut out by the Sun. The heliopause's distance from Earth was a mystery to us when the spacecraft was launched. Considering that Jupiter is just 5 times further from the Sun than Earth, some have suggested that the heliopause could be located there. Estimates of the distance to the heliopause increased as the spacecraft accelerated further outward. There is no doubt that it wasn't Jupiter, Saturn, Uranus, or Neptune. No one was aware of the precise location or time of Voyager's entry into interstellar space. Voyager noticed signs of the heliopause not long after it encountered Neptune. In July 1992, the two Voyagers began to detect powerful radio signals at frequencies between 2 and 3 kHz. Some scientists link these radio waves to 6 large solar flares that took place more than a year before they were discovered. The plasma that was ejected during the flares eventually found its way to the heliopause, where it caused electrons to oscillate and emit radio waves, according to the researchers' results. Despite being so weak as to be mistaken for a clean vacuum on Earth, the local interstellar medium is far denser than the outer heliosphere. The distance of the heliopause from the Sun was also determined by knowing the estimated speed of the outward solar material and the time it took for it to reach the boundary. The distance of the heliopauls from the Sun was determined by knowing the estimated speed of the outward solar material and the time it took for it to reach the boundary. The average distance between the Sun and Earth is 1 astronomical unit, and this distance ranges from 116 to 177 astronomical units. On August 25, 2012, at a distance of 121.6 astronomical units, Voyager 1 crossed the heliopauls. There were a few obvious indicators that Voyager 1 had gone through the heliopauls. High-energy solar wind particles started to evaporate, which was probably a sign that the rest of the solar wind had also been left behind. In addition, cosmic rays from beyond the solar system, which is partially obstructed by the heliosphere, intensified following Voyager's passage. However, many researchers were unconvinced by this evidence alone. There were two distinct problems. First, Voyager 1's plasma instrument had malfunctioned, preventing it from capturing the dramatic rise in particle density that happened when it left the heliosphere and reached interstellar space. Second, a different direction for the magnetic field to point toward beyond the heliosphere was predicted, but this did not materialize. The cause of the coincidence of the magnetic fields inside and outside the heliosphere has not yet been adequately explained. The Sun played a role in Voyager's success. Early in 2012, solar storms started to erupt, and the following year they shocked the plasma that Voyager 1 was traversing. The Sun played a role in Voyager's success. Early in 2012, solar storms started to erupt, and the following year they shocked the plasma that Voyager 1 was traversing. As a result, the plasma's electrons began to oscillate, which in turn led to the radio waves that the spacecraft was able to detect. These radio waves frequencies indicated that Voyager had entered a much denser area. 2018 saw Voyager 2 make its heliopauls crossing on November the 5th. This time there were no questions raised by the passage. The spacecraft's plasma instrument was in use and able to monitor the increase in particle density brought on by protons, electrons, and other charged particles colliding with it. It also noted the temperature, which was between 30,000 and 50,000 Kelvin, and was much greater than that of the neighboring interstellar medium. The plasma was probably compressed when it entered the heliosphere, which is why this happened. Similar to Voyager 1, the probe saw the solar wind diminish and the amount of extrasolar cosmic rays rise. However, the magnetic field did not reverse course once more, proving that the outcome from 6 years earlier was not an exception. The relatively close distances suggest that the heliopauls is stronger than previously thought. Voyagers 1 and 2 are still traveling away from the heliosphere, whatever its precise shape may be. Since the spacecraft signals travel at the speed of light, it will take them more than 22 hours to get to us. When Pioneer 10 finally goes silent in late 2023, Voyager 2 will have traveled 129 astronomical units, and it will overtake it to become the second farthest spacecraft ever. The two Voyagers are traveling in opposing directions and are further off from Earth than any of them is. Scientists said that Voyager 1 had captured a humming sound that was connected to waves detected in minute quantities of gas located in the almost empty region between stars. The Voyagers lose power as the plutonium decays and produces less heat. In order to make up for this, NASA reported that the team disabled all systems, including several that were first thought to be vital. There are heaters among them, which protect still working instruments from the bitter cold of space. The space agency said that all 5 of the devices, whose heaters have been off since 2019, are still functioning. How the Voyagers can continue to function in temperatures much below what they were designed for continues to baffle NASA researchers. The Attitude Articulation and Control System, AACS, of the probe also experienced a malfunction the year before. This was the mechanism that makes sure the probe's antennae are pointed toward Earth. Up until this moment, the probe's performance had been flawless with no known interference. Through an onboard computer that had stopped working years earlier, the confused probe began transmitting incorrect telemetry data, corrupting the proper data in the process. The probe lost track of its location in orbit as a result. The Voyager's slide raises the question of whether or not it is time to retire one of the agency's oldest and farthest traveling space probes, even though NASA specialists only recently were able to resolve the issue by instructing the system to return back to its previous computer. Even though the government claims that the error won't affect the mission's long-term viability, a number of scientists have already started investigating the prospect of creating Voyager's replacement. Nobody is certain how long the two spacecraft will last. They must stay heated in order to prevent the fuel that keeps their antennae directly toward Earth from freezing. Plutonium is responsible for Voyager's heat production, but as it decays, it produces progressively less energy each year. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.